Welcome back to our course in trigonometry. We've got one more preliminary concept to get through before we delve into the trig functions. And in this video we are going to discuss three things. Firstly, an angle in what we'll call standard position. And we'll also talk about a way to make sense of negative angles, and we'll talk about what coterminal angles are. Okay, so when we talk about an angle in standard position, here's what I want you to picture. We think about the xy plane, and we imagine that we are taking the positive x-axis, and we are rotating that positive x-axis in the counterclockwise direction. Okay. So if we take that positive x-axis and rotate in the counterclockwise direction through angle theta, whatever theta is, if theta is 20 degrees, well, that's 20 degrees in standard position. Okay, so that's our idea of an angle in standard position. In fact, let me make a little arrow here to indicate that we have rotated in that direction. Okay, so if we have an angle in standard position between 0 and 90 degrees, that's going to be in this region right here, quadrant 1, okay? You'll notice that the x and y axis divide the plane into 1, 2, 3, 4 pieces. Quadrant 4, okay? So if you got a quadrant, you're going to have 4 of them. Okay, Q1 is over there. Angles between 0 and 90 degrees will land you in Q1. If you rotate past 90 degrees, but don't quite go the full 180, you're going to be in Q2. Quadrant 3, you got to rotate more than 180, but less than 270. And quadrant 4 is angles between 270 and 360. Okay, so standard position, you're imagining the positive x-axis, okay, so you kind of imagine putting a pin right here, put a push pin in the origin so that this part of the x-axis stays the same. You're rotating the positive x-axis through whatever angle that we're discussing. Okay. Now, making sense of a negative angle. Well, it's actually not a hard idea. Okay, so let's go and think about the angle of, I don't know, 75 degrees in standard position. So it would take us to right about there. Once again, we're thinking positive x-axis rotated in the counterclockwise direction. The way to make sense of a negative angle, well, we go the other direction. Okay, so negative 75 degrees would take us down here. Okay, now that actually dovetails pretty nicely with this last idea of coterminal angles. So we got angle in standard position, take the x-axis, rotate in the counterclockwise direction. Negative angle, go the other way. Go the clockwise direction. Now, coterminal angles are angles that will land you in the same place. Okay, so negative 75 degrees gets you here into quadrant 4. Okay, but you could have also gone around this way, and you'd end up in the same place. Okay, so let me think about that. Right, this must be 15 degrees, right, because 90, 180, 270. Now, if I went 270 to 360, I'd be back at the x-axis. It would look like I hadn't done anything, right? So if that's 75 degrees, this must be 15, because they got to add up to 90. Okay, so 180 plus 15, 195 degrees. So 195 and negative 75 are coterminal angles. Nope. Yeah. That is wrong. It's not 195 degrees, that's 270 plus 15. 285 degrees. And negative 75 degrees are coterminal. Okay. So there's two ways to get to this place. In fact, there's infinitely many ways. Because what you can do is you could do the full 360 and then go around 285. Okay, so there's infinitely many coterminal angles with whatever it is your angle ends up at. Okay, so your angle gets you to a place, let's say 75 degrees. That would be coterminal with going around the full 360 and then going an additional 75 degrees, getting you to 435. So 75 and 435 would be coterminal. Okay, there's an infinite number of coterminal angles. You just got to throw in a full 360 and it'll get you to the same place, because doing a full 360 would be turning completely around and you end up where you started. Okay, so key ideas once again: know what an angle in standard position is, know how to make sense of negative angles, and know what we mean when we talk about coterminal angles. You can always add a multiple of 360 degrees and get back to the same place.